Quantum mechanics. Superposition and collapse of the wave function. In the quantum world, particles can be in superposition, i.e., in several states at the same time. Only upon observation measurement does the wave function collapse and the particle assumes a particular state. This is similar to how in a computer game, objects are only drawn when the player's camera is pointed at them. This begs the question, does objective reality exist outside of our observation, or is it only generated when we look at it? Quantum entanglement. Two or more particles can be entangled in such a way that a change in the state of one instantly affects the state of the other, regardless of the distance between them. This phenomenon violates the principle of locality, which states that objects can only interact with their nearest neighbors. One can imagine that entangled particles are like pixels on a screen that change color at the same time, regardless of their location, because they are controlled by the same software code. Corpuscular-wave dualism. Quantum objects can exhibit properties of both particles and waves depending on the experimental conditions. This phenomenon is difficult to imagine within the framework of classical physics, but it can be explained if we consider our reality as a simulation where objects can have different properties depending on the program that creates them. Discreteness and quantization. Many physical quantities in the quantum world, such as energy and momentum, are quantized, meaning they can only take on certain discrete values. This is similar to how in computer games, graphics are made up of pixels and sound is made up of samples, that is, all quantities are discrete and have a minimum unit of measurement. Role of the observer. In quantum mechanics, the role of the observer plays an important role because the act of observation affects the behavior of particles. This can be interpreted as evidence that our reality is a subjective experience created by our minds, rather than an objective reality that exists independently of us. Deja vu? This is the feeling that we have already experienced the current moment, familiar to many. In terms of the simulation hypothesis, deja vu can be explained as a glitch in a program when the same piece of code is run twice. Synchronicities. These are meaningful coincidences that seem too improbable to be coincidental. For example, you're thinking about an old friend you haven't seen in a while, and at the same moment he calls you. From a simulation perspective, synchronicities can be explained as planned events that are designed to guide us along a certain path or give us a clue. Unexplained phenomena. There are many unexplained phenomena that do not fit into the framework of modern science, such as telepathy, clairvoyance, ghosts, and UFOs. From a simulation perspective, these phenomena can be explained as bugs in the program or interference by the simulation creators. Mandela Effect. This is a phenomenon where large numbers of people have false memories of events that never happened. For example, many people remember that in the Looney Tunes cartoon a character is called the Berenstain Bears, although he is actually called the Berenstain Bears. From a simulation perspective, the Mandela Effect can be explained as a change in the simulation code that results in a change in the past. Prophetic dreams and premonitions. Some people claim to have dreams or premonitions about future events that then come true. From a simulation perspective, this can be explained by accessing information about the future that is already embedded in the program. Technology. Virtual reality. VR technologies allow the creation of increasingly realistic and immersive virtual worlds. With the development of VR equipment such as virtual reality helmets and suits with haptic feedback, the boundaries between real and virtual worlds are becoming increasingly blurred. Artificial intelligence. AI is rapidly evolving, and there are already programs that can learn, solve complex problems, and even show signs of creativity. With the development of AI, we may in the future create artificial beings indistinguishable from humans in their intelligence and behavior. Computing power. The processing power of computers continues to grow exponentially, following Moore's law. This means that in the future we will have enough computing resources to create complex and realistic simulations. Neurointerfaces. Scientists are developing neurointerfaces that allow you to directly connect your brain to a computer. With the development of this technology, it will be possible to create simulations that directly affect our senses and perceptions, making them even more realistic. Simulations in science. Scientists already use computer simulations to model a variety of phenomena, from climate change to the behavior of elementary particles. As technology advances, simulations will become more accurate and sophisticated, moving closer to creating virtual worlds indistinguishable from reality. Fractal nature of the universe. Many objects and phenomena in nature have a fractal structure, that is, they consist of repeating patterns at different scales. For example, tree branches, snowflakes, coastlines, and even galaxies exhibit fractal properties. This may be a hint that the universe itself has a fractal structure where simulations exist within other simulations, creating an infinite hierarchy of realities. Dark matter and dark energy. These mysterious substances make up most of the mass and energy of the universe, but we cannot directly observe them. Their existence is postulated to explain gravitational effects that cannot be explained by visible matter. From the point of view of the simulation, dark matter and dark energy may simply be crutches in the software code that are used to adjust the behavior of the simulation. Fine-tuning the universe. Physical constants such as the speed of light, the gravitational constant, and the mass of an electron have very precise values that are necessary for life to exist. Even a small change in these constants would make the universe unfit for life. This could be a sign that our universe has been finely tuned for us by the creators of the simulation. The Fermi paradox. If there are so many stars and planets in the universe, why have we still not detected any signs of extraterrestrial life? This contradiction can be explained by the fact that our simulation is limited and contains no other intelligent beings. The arrow of time. Time moves in only one direction, from the past to the future. This phenomenon has no explanation in the fundamental laws of physics, which are symmetrical with respect to time. From a simulation perspective, the arrow of time may simply be a feature of the program that creates our reality. Holographic Principle. This theory suggests that our three-dimensional universe may be a projection of information stored on a two-dimensional surface. This is similar to how a hologram creates a three-dimensional image from a two-dimensional film. The holographic principle may be an indication that our reality is a simulation created on some cosmic computer. Sense perception. Our senses provide us with limited and subjective information about the world. We see only a narrow range of the electromagnetic spectrum, hear only certain frequencies of sound, etc. It is quite possible that there is much more information about the world that we are simply unable to perceive. In terms of the simulation, our senses may simply be an interface that converts information from the simulation into a form accessible to our perception. Qualia. Qualia are the subjective qualities of our experience, such as the sensation of color, taste, smell, and pain. It is difficult for science to explain how physical processes in the brain produce qualia. From a simulation perspective, qualia may simply be data that is transmitted to our consciousness from the outside. Dreams and altered states of consciousness. In dreams or under the influence of psychedelics, we can have vivid and realistic experiences that have nothing to do with physical reality. This shows that our consciousness is capable of creating its own worlds independent of external stimuli. From a simulation perspective, this could be a sign that our reality is also a kind of dream or illusion. Psychological experiments. Some psychological experiments, such as the split brain experiment, show that our consciousness can be divided into several independent modules, each with its own subjective picture of the world. This may be a sign that our reality is not a unified whole, but rather a set of separate fragments that our consciousness puts together. Philosophy. Nick Bostrom's simulation argument. Swedish philosopher Nick Bostrom, in his article Are We Living in a Computer Simulation?, offered the following argument. If civilizations do not die out before they reach a technological stage capable of creating realistic simulations, then the probability that we are living in a baseline reality is extremely low. If we are living in a simulation, then our perceptions of the physical world may be illusory, and the laws of physics may simply be rules established by the creators of the simulation. If we are in a simulation, it is entirely possible that there are other simulations created within our simulation, and so on ad infinitum. Skepticism. Skepticism is a philosophical movement that questions the possibility of reliable knowledge of the world. Skeptics argue that our senses and reason can deceive us, and that we cannot be certain of anything other than our own existence. The simulation hypothesis fits well with this approach because it suggests that our reality is an illusion created by our minds or some external source. Idealism. Idealism is a philosophical trend that holds that reality is a mental construct and that the material world exists only in our minds. From the perspective of idealism, the simulation hypothesis can be interpreted as evidence that our reality is a product of our consciousness or some higher mind. Solipsism. Solipsism is an extreme form of idealism that states that there is only one consciousness, my own consciousness, and everything else is an illusion created by that consciousness. The simulation hypothesis can be interpreted as a confirmation of solipsism because it suggests that each of us may simply be a program running in its own simulation. Brain-in-a-flask theory. This thought experiment suggests that a person's brain could be removed from the body and placed in a nutrient-rich environment where it would receive all the necessary signals from the outside world through electrodes. The brain in the flask would not be able to distinguish between simulation and reality, as all its sensations would be artificially created. The simulation hypothesis is a kind of extension of this thought experiment, suggesting that not just a single brain, but entire universes can be simulations.